Morning, CLB students. So, all of you doing the experiments, it's important that we think about what's happening to the chemistry. Okay. So most of you know it's a dance between the bacteria and the archaea. The bacteria does the initial job, and then the archaea or the methanogens do the conversion to methane. We did in CBI a 3 population model. This is now a 4 population model where we included the homoacetogens. Okay, so just have a look. All the monomers, of course, the breakdown of the monomers is another process facilitated by enzymes that might take some time, but once you got your monomers, it's basically a breakdown to volatile fatty acids, and initially all will go to acetic acid, but in the process you also make hydrogen and you also make CO2. Then there's an interesting, we haven't discussed this in CBI, but there's a type of acetogen referred to as the homoacetogens that uses hydrogen and CO2 to produce acetic acid. Okay, they are in a sense competing with the hydrogenotrophic methanogens, which also use the same substrate, hydrogen and CO2, to make methane. Okay. Now, when we talk about hydrogen, you can see I say NADH here. I want you to understand it might end up as hydrogen gas, but typically we think of this as a high energy electron contained by, or two of them, two high energy electrons contained by NADH. These are the electrons that we get our energy from respiration. So if you have oxygen, you do respiration, you get a lot of ATP. There's a lot of energy in that electron. So what happens in our digester is that typically this electron is not released as hydrogen, even though we model it as hydrogen. It's called interspecies electron transfer. So NADH of the acidifiers will be transported directly, or the electrons of that NADH will be transported to the homoacetogens, which is one scenario. When they get hydrogen, they take CO2, they make acetic acid, but it can also be transported to the hydrogenotrophic methanogens, which use the same substrate. So it's not hydrogen they receive, it is really them receiving two high energy electrons, which enables the process of making methane. Of course, in our reactor, especially there's 3 of them still struggling. We'll look at that today. You now have a problem that all your hydrogen and CO2 will be consumed by the homoacetogens. Typically in a healthy system, there's a balance between the homoacetogens and the hydrogenotrophic methanogens. So we are in those systems reliant on directly converting the acetic acid to methane and CO2 via the acetoclastic methanogens. So this picture, very important. Remember, hydrogen is the electron, the high energy electron from photosynthesis. It's really all about how do we handle that. If we release it as hydrogen, we lose a lot of energy. If we get it into the homoacetogens or the hydrogenotrophic methanogens, we are in the process of making our combustible biogas. Okay, short video, but important that you guys understand it. Have a great weekend.